Nothing says you've arrived in the southern part of the United States faster than sweet tea and pine trees. Among all of the species of trees on this planet, this tree has more utility than probably any other tree that you'll discover. And when I'm done in this next episode, you're going to know more about the southern pine than you ever thought you'd want to know. Hi, I'm Jeff Packer, and I'm your channel host and chief nature lover. My background is technology, but my passion is wood. And you've reached the Wood Channel, a place where we discover and learn about the practical benefits and uses of the rarest resource in the universe, trees. Let's go. Welcome to the Wood Channel. I'm Jeff Packer, and today we're bypassing the workshop, skipping the fine furniture, and leaving the exotic hardwoods behind. Instead, we're shining a light on a multi-billion-dollar piece of global infrastructure that keeps modern civilizations running, the humble utility pole. There are over 150 million of these wooden pillars stretching across North America alone. Think about that number for a second. Millions of miles of high voltage wire draped across a network built almost entirely from trees. Not steel, not concrete, not advanced carbon fiber, but wood. And the vast majority of this massive network relies on a very specific group of trees known collectively as the southern yellow pine. An entire massive industrial complex has grown up around planting, managing, harvesting, and chemically engineering these trees to do what sounds completely impossible. We ask them to bury themselves in wet, bacteria-ridden mud. We ask them to support thousands of pounds of live, dangerous voltage. We even ask them to face down 100-mile-per-hour winds without snapping. And we expect them to refuse to rot for over 50 years. So how does a living plant become the literal backbone of the modern electrical grid? If you want to build a continent-spanning power grid out of timber, you can't just wander out into some random part of the forest and start cutting down trees. If you used an oak tree, for example, it would be too twisted. If you use, say, a willow, it would rot in months. If you used a redwood, well, it'd be too expensive and structurally soft. You need a tree that behaves exactly like a factory-produced steel beam. That is where Pinus pallatris and Pinus tiata come in, better known as longleaf and loblolly pine, the heavy hitters of the southern pine family. These species are native to the American South, and they possess a unique biological superpower known to botanists as apical dominance. This means the main central stem of the tree grows dramatically faster and stronger than any of the side branches. These trees hunt the sun with a vengeance. They shoot straight up towards the canopy like a rocket. And because the commercial timber industry plants them incredibly close together in massive, mathematically organized plantations, a fascinating natural phenomenon occurs. Because the trees are crowded, the lower branches receive zero sunlight. Deprived of light, the tree naturally sheds those lower branches early in its life cycle. It prunes itself. Why does this matter to an engineer? Because every branch a tree grows leaves a permanent knot in the timber when it's harvested. In the world of structural engineering, a knot is a structural catastrophe. It alters the direction of the wood grain and creates a localized point of weakness where the wood can split under pressure. Because southern yellow pine self-prunes so efficiently, it creates long, uniform, flawlessly vertical trunks completely free of major knots. But straightness is only half the battle. The real secret to this tree's dominance lies at the microscopic level, hidden within its cellular density. If you look at a cross-section of a southern yellow pine log, you'll notice highly distinct dark bands. That is late wood, the dense wood cells grown during the late summer months. Southern yellow pine produces a massive volume of this thick wall, heavy fiber compared to other soft woods. This specific biological trait gives it a modulus of elasticity and a bending strength that rivals engineered steel. It allows a 40-foot pole to flex several feet under extreme wind loads, safely absorbing the kinetic energy of a hurricane and then springing right back into a perfect vertical position. But nature, for all its brilliant design, left one fatal flaw in the system. Wood is organic matter, which means it decays. The moment you take a perfectly straight pine trunk, strip its bark, and bury it 6 feet deep into damp, warm, insect-rich soil, you have essentially set up a 5-star, all-you-can-eat buffet for fungi, termites, and wood-boring beetles. Left to its own devices, a raw pine log in wet soil will lose its structural integrity and collapse within 3 to 5 years. To turn this tree into a 50-year asset, the timber industry had to step away from forestry and completely weaponize industrial chemistry. Once a pine pole is selected, stripped of its bark and machine framed, it doesn't get painted or sprayed with a top coat. Surface treatments are useless. They just peel off. Instead, the logs are loaded onto rail cars and rolled into the belly of an industrial beast, a massive, thick-walled steel pressure cylinder called a retort. And this, my friend, is where the transformation happens. Once the heavy steel doors are locked shut with massive hydraulic clamps, powerful pumps turn on and pull a massive vacuum inside the cylinder. This vacuum literally sucks the air and remaining moisture right out of the microscopic cells of the wood, leaving millions of tiny cellular cavities completely empty. While the vacuum is held, the cylinder is flooded with a heated chemical preservative, often an oil-borne solution like creosol or a waterborne compound like chromate, known in the industry as CCA. Once the cylinder is full, the pumps reverse. They stop pulling a vacuum and begin slamming the liquid inside under immense pressure, upwards of 150 to 200 pounds per square inch. This massive hydraulic force violently drives the chemical deep into the wood's open sapwood layers, forcing it directly into the cellular walls. If you ever look closely at a cut utility pole, you'll see a highly distinct dark outer ring that penetrates a few inches deep into the timber. That is the treatment zone. The heartwood at the absolute center of the tree is naturally dense and tight, but this chemically altered outer ring of sapwood acts as an impenetrable shield. The chemistry here is brilliant. The copper in the solution acts like a powerful fungicide, stopping rot and mold in its tracks. The arsenic acts as a devastating insecticide, ensuring that any termite or beetle that attempts to take a bite is instantly stopped. Meanwhile, the chromium acts as a chemical fixing agent, locking the entire compound permanently into the wood fibers so it can never leach out into the surrounding soil or rainwater. The process alters the material properties of the wood. It turns an organic, perishable plant into a semi-synthetic composite material. It becomes toxic to everything that wants to degrade it and completely indifferent to groundwater, moisture, and essentially frozen in time. When you look at the sheer scale of this operation, it becomes staggering. Every single year, millions of these engineered poles are grown, harvested, pressure treated, and deployed into the field. It is quite the monumental effort by an industry that works around the clock to keep our lights on. But this raises a glaring modern question. Why are we still using wood in an age of high-tech composites, carbon fiber, galvanized steel, and advanced metals? Why is the most advanced electrical grid on the planet still sitting on top of tree trunks? The answer comes down to a mix of brilliant physics and cold, hard economics. First, let's talk about safety. Wood is a natural electrical insulator. If a high voltage wire snaps during a storm and lands on a steel utility pole, that entire pole becomes a live, lethal lightning rod, conducting electricity straight down into the ground or anyone that touches it. If that same live wire falls on a treated wooden pine pole, the wood safely resists the current. It keeps the danger contained. Secondly, think about resilience. Steel poles rust, especially in salty coastal environments or humid climates. Concrete poles are incredibly brittle. If an earthquake hits, or if a car crashes into one, concrete cracks, shatters, and suffers catastrophic structural failure. But wood loves to flex. It handles localized impacts, shifting soils, and seismic vibrations better than almost any rigid man-made material. And then there's the factor of weight and logistics. Concrete poles are immensely heavy and require massive specialized cranes just to lift them into place. A pine pole is relatively lightweight, highly portable, and can be easily installed by a small utility crew using a standard truck in the middle of a remote forest. But the absolute best part about using southern yellow pine, it is entirely renewable. Unlike steel, which requires open pit mining, coal-fired furnace blasts, or concrete, which requires massive amounts of carbon emissions during manufacturing, utility poles are essentially a crop. They are grown in sustainably managed forests that actively absorb carbon dioxide from the atmosphere while they grow. For every single pine tree the utility industry harvests, forestry managers plant up to 3 more in its place. It is a fully circular, self-sustaining, positive loop. So the next time a violent summer storm hits your neighborhood, the wind is howling against the window, and you hear the branches snapping outside, take a second to look out of the window. Watch the lights flicker, stabilize, and then stay on. And give a silent nod to that green-tinted, battle-tested pine soldier standing outside there in the rain. It isn't just a telephone pole. It is a masterclass in natural engineering and human chemistry, quietly holding our modern world together, 1 volt at a time. Did I make good on my promise? Did you learn something? I certainly hope so. But to continue this journey, please like and subscribe to the channel. You have an interest in forestry or woodworking, please visit our website at thewoodchannel.com. You'll find all kinds of information on our active events and sponsorships, and make sure you check out our channel sponsors. And please shop our merch store. Hey, we've got all kinds of wood gifts there, wood-related products for the person who just loves trees like me, and we're always looking for educational speaking opportunities. So if you have one, I'm interested. Look, thanks for visiting the Wood Channel, where you know if it's wood, it's all good.